Hi everyone, and welcome to exercise 3 of HSMA session 1F. That's the second Python programming session from HSMA 6 this year. Now, these are two exercises around the use of the Numpy library, so I'm going to kick off pretty swiftly by importing Numpy. So the standard for importing Numpy is import Numpy as NP. So just to let you know, if you start typing and it comes up with something like this in your VS Code, trying to give you some suggestions, if you press enter, you will find that it autocorrects itself to whatever the suggestion was. This can be a little bit annoying. So what I would recommend is you get to import numpy as np and press space, and that will get you away from that automatic suggestions and allow you to keep np as the keep what you've entered. So as I say, np is the standard kind of import statement for numpy, and this is what you'll see in lots of code examples online, etc. So it's a good idea to follow this convention. That being said, just importing it as numpy would work absolutely fine. Now, I'm going to change this back to what I wanted, and I'm going to kick off by trying to create two numpy arrays. So we've been asked to create two arrays, one with all of the odd numbers from 1 to 999,999, the other with all of the even numbers starting at 2 and ending at 1 million. So what I'm going to do is I'm going to create an array. I'm going to call it odds array, and I am going to use the numpy arange feature. So this is a feature to create an array range. That's where the A comes from in this, I believe. So I'm going to do np arange, and you might remember the range function that we used in base Python. We've used this when we've been doing for loops, for example. Now that returns something called a range object. The arange function has a couple of differences. It returns a numpy array. It's also a little bit more flexible. You can actually use non-integer values, either as your start, your finish, or your step, I believe. Although there are some other recommended functions that numpy themselves would suggest you use instead, but they would work for that. So what I'm going to do is I'm going to start off by saying I want the number that we're going to start at to be 1. So we wanted to go for all our odd numbers from 1 to 999,999, and actually I want to go up to 1 million. Why do I want to do this? So we'll just check we've got the right number of zeros. 1, 2, 3, 4, 5, 6. Yeah. So the number that we go up to, this second number, won't be included. So the last number in our array will be the one before this, depending on the size of our step, the last number in the sequence before this number. So just to demonstrate that, I'm going to say I want to go from 1 and I want up to 1 million, and I want a step of 2. So what this will do is it'll go 1, 3, 5, 7, 9, so on and so forth. I'm just going to print that a second so you can see what I mean. And you can see we've got, as I say, 135, and then we've got 999, 995, 999, 997, and 999, 999, which is what we have been asked for. So, and you can see actually the 3 dots here just mean there's something else in the middle. Pandas or even NumPy is quite nicely here. It's not displaying the entire thing for us. That would be a rather large array. Let's see actually, can we see how long this array is? Yep, so of course it's 500,000 numbers long. We are quite glad that that hasn't been printed automatically for us. So the next thing I'm going to do is I'm going to create my array of evens. So this time it's arange again. I want to start at 2. And let's see what happens if we said, actually, I want to go up to 1 million. That is 100,000. I need one more zero there. Stepping up by 2. And I'll just print this array. And you can see the problem here. We have got 246, started from 2 as we would like, but actually our last number in the array is 999,998. And that's because we said we only want to go up to 1 million. 1 million won't be included. So what we need to do here is say, actually, please, can you just make that 1,000,001 that you will go up to? If I run this again now, you will see that 1 million is included in the array, we're still starting from 2, and if we print the length of this one again, then we have got 500,000 numbers in our array. Now this is important actually, because the next thing we've been asked to do, calculating the dot product of these arrays, that won't work if we've got two arrays of different length. It will just fail on us, and that is not what we want. So we need to be passing in two identical length arrays, which we have determined we've got, both 500,000 numbers long. So dot product. Just as a quick reminder, dot product gets quite complicated when you're working with multi-dimensional arrays, but actually for this exercise we're just doing two one-dimensional arrays and getting the dot product of those. So in this case that means we will be multiplying this element here, the 1, with this element here, the 2, and actually going, okay, 1 times 2 is 2. Then we're going to go this element here times this element here, so 2 times 4 is 8, 3 times 6 is 18. We're then going to add all of these together. Now for our array, all that will mean is we do that across the entire array. So all the way up to, for example, if I print our odds array and print evens array, this will go all the way up to 999,995 multiplied by 999,996, and adding that onto all of the additions we've done up until that point, and so on all the way up to the final pair of numbers across the two arrays. So all we need to do to get the dot product is dot odds evens. So I could call this anything, just dot product or something. We're going to use the np.dot function. So I'm going to say odds array times by the evens array. So I'm not using times, I'm actually, so the dot product expects just two arrays to be passed to it with a comma separating it, and I'm then going to print the output. Now, when I run this number on the face of it looks like it actually is, you know, maybe quite plausible. It's quite hard off the top of our head to kind of comprehend the scale of this calculation. However, there is a limitation on the Numpy implementation on Windows that means this number is not actually stored correctly. This number is too big for Windows to store or for Numpy to store when we use the default data type. So actually the only little thing we've got to do here is say, please, can you store the numbers in our arrays as integer 64 numbers? Now, this isn't something you're likely to run into very often. This is a very large calculation that isn't going to be part of your day-to-day, but just be aware that actually if you're working with very large numbers, you may want to force your arrays to be using the integer 64 data type. This isn't a problem on Linux or Mac, I believe. Definitely not on Linux. Don't think it's a problem on Mac as well, and that's because they by default will be using this data type. I think that's the reason. So if we run this again, you can see now we've got a much larger answer, and that is just because we have managed to actually store all the data relating to the calculation that we are trying to undertake. But that's all there is to this exercise. We've created our two arrays, we've taken the dot product of them, and we have printed that out.